Good evening to everyone. Myself Souvik Dutta. In the last class, we have studied about the energy signal and power signal. Now today, I will tell about the periodic and the aperiodic signal. Okay. So we know that in time domain, a signal is said to be periodic when we can write it mathematically like this way. That is x of t plus capital T is equal to xt, where t is called the period, time period of the signal or period of the signal. That means, suppose if we consider a sinusoidal signal or cosinusoidal signal, that is there in that situation t capital T will be equal to 2 pi. That means every after 2 pi time period 2 pi, the same thing, the same signal is repeating. Okay. In the same way, in the discrete domain, we can write this expression like this way, that is x of n plus capital N is equal to x of n, where capital N is called the fundamental period of the signal. Where capital N must be an integer. Okay. Now, if we consider an example, that means suppose a question we are considering xn is equal to a sine omega naught n. Okay. Now, if we need to find the fundamental period of that signal, that means x of n plus capital N, we can write a sine omega naught n plus capital N. Okay. Or we can write a sine omega naught n plus omega naught into capital N. Okay. That means that signal is said to be periodic when omega naught into capital N is a integer multiple of 2 pi. Okay. That means m is an integer as well as capital N is an integer. And from there we can find the fundamental period capital N is equal to 2 pi by omega naught into m. Okay. This is the formula for finding the fundamental period of a signal. Now we will solve one to numerical to understand this formula. That means suppose consider xn is equal to sine 2 pi by 3n. Okay. Now check whether this signal is periodic or not. If periodic, find the fundamental period. Now for finding the fundamental period, we need to apply the formula, that is 2 pi by omega naught into m, where if we consider the expression with the standard expression, that is xn is equal to sine omega naught n, then we will get omega naught is equal to 2 pi by 3. Now if we replace this omega naught here, we will get 2 pi divided by 2 pi by 3 into m. Now if we simplify it, we will get 3m. Now the minimum value of m for which n becomes integer is that when m is equal to 1, then n becomes 3. Okay, so minimum value of m is equal to 1. Okay, for that n becomes integer, that is n is equal to 3. That means the signal is periodic with a fundamental period capital N is equal to 3. Okay, now we will solve another numerical, that is xn is equal to e to the power j 6 pi n. Now the question is that check whether this signal is periodic or not, and if periodic, find the fundamental period. Now to do this, we will compare this expression with the standard expression, that is xn is equal to e to the power j omega naught n, where omega naught is equal to 6 pi. Okay. Now we know the formula for fundamental period, that is n is equal to 2 pi by omega naught into m. Now if we replace omega naught here, that is 2 pi by 6 pi into m, that is 1 by 3 into m. Now if we take m is equal to 3, then we will get n is equal to 1. Okay, that means the minimum value of m is equal to 3. For that m becomes integer, that is n is equal to 1. That means the signal is periodic with a fundamental period capital N is equal to 1. Okay, now we will solve another numerical, that is xn is equal to e to the power j 6n. Okay, now it has been asked that check whether this signal is periodic or not. If periodic, find the fundamental period. Okay, now to solve it, we will compare this with the standard expression, that is xn is equal to e to the power j omega naught n, where omega naught is equal to 6. Okay, now if we write the expression, n is equal to 2 pi by omega naught, that is 2 pi by 6 into m, that is uh, pi by 3 into m. Okay, now if we take any value in any integer value of m, n cannot be an integer. Okay, because the presence of pi. Okay, so that type of signal is not periodic because there is a existence of pi. Okay, so this type of signal is called the aperiodic signal. Okay, now we will study another numerical, that is the summation of two signals. Now the two signals are there. Suppose xn is equal to x1n plus x2n. Okay, now it has been asked that check whether the signal is periodic or not. If periodic, find the fundamental period. Now for that situation, the process will be that first we need to find the fundamental period of x1n, that is n1 we are considering. Similarly, the fundamental period of x2n we are considering, that is n2. Now for the signal to be periodic, n1 by n2 ratio, that is n1 by n2, must be a rational number. If n1 by n2 ratio is a rational number, then the signal is said to be periodic, otherwise not. And what is the formula for the fundamental period of the overall signal? That is n is equal to LCM of numerator of n1 comma n2 divided by HCF of denominator of n1 comma n2. This is the formula for finding the fundamental period of the overall signal. Now we will consider one numerical to understand this. That is xn is equal to 2 sine 2 pi by 3n plus 4 sine 2 pi by 7n. Okay, now check whether this signal is periodic or not, and if periodic, find the fundamental period of the overall signal. Now for doing that, suppose we are considering x1n is equal to 2 sine 2 pi by 3n. Okay, and from there, if we consider the expression x1n with the standard expression, so from there we will get omega naught 1 is equal to 2 pi by 3. Okay, and from there we can find the fundamental period, that is 2 pi by 3 into m. that is 3m, that is 3 when m is equal to 1. Okay, similarly x2n is 4 sine 2 pi by 7n. Okay, now omega naught 2, that is the frequency is 2 pi by 7. Okay, n2 is 2 pi divided by 2 pi by 7 into m, and from there it will be 7m, that is equal to 7 when m is equal to 1. That is the fundamental period n1 for the first case is n1 is equal to 3, and for the second case n2 is equal to 7. Now if we take the ratio of that signals fundamental periods, that is n1 by n2, that is we will get 3 by 7. Okay, so this is a rational number. Now if we need to find the fundamental period, so the signal is periodic. Now if we need to find the fundamental period of the overall signal, so the formula is already I have told, that is n is equal to LCM of numerator of n1 n2 divided by HCF of denominator of n1 n2. Okay, so LCM of numerator of n1 n2, that is LCM of numerator of, that is LCM of 3 comma 7, and HCF of denominator of n1 n2, that is n1 value we have found 3, and n2 value we have found 7, that is 3 by 1 7 by 1. So LCM of 3 comma 7 and HCF, there is highest common factor of denominator, that is 1 comma 1, that is 1 comma 1, that is 21. Okay, so fundamental period of the overall signal we are getting, that is 21. So the signal is periodic with a fundamental period 21. Okay, so this is the another type of example. Okay, from there if there is a summation is there, so first we need to check whether the ratio of their fundamental period is a rational number or not. If there is a rational number, then the signal is periodic, and from there we can find the fundamental period of the overall signal. Now we'll study another type of signal, that is called the even signal and odd signal. Even signal and odd signal. So we know that even signal we write, that is x of minus n is equal to xn, that is the co-sinusoidal signal. And odd signal, that is x of minus n is equal to minus xn, that is sinusoidal signal. Okay, now we know that any signal is consist of two part, even part and odd part. That is, we can write xen, even part, as well as the odd part of a signal. Okay, every signal, any signal consists of two part, even part and odd part. Now if we replace n by minus n, we can write, now take this as equation number 1. Now if we replace n by minus n, we can write x of minus n. So here it will be xc of minus n plus x0 minus n. Okay, so we know that for even signal, x of minus n is equal to, already I have shown, x of minus n is equal to xn. So we can write here xc of minus n, that is xn, and for odd case we can write x of minus n is minus xn. So here we can write that is minus x naught n. This is number 2. Okay, now if we add 1 plus 2, what we will get? If we do 1 plus 2, we will get xn plus x of minus n x. This one and this one will cancel each other, so we will get 2 xen. So from there we can write xen is equal to, even part of a signal, we can write half of xn plus x of minus n. Okay, similarly if we do 1 minus 2, we will get the odd part of the signal, that is x naught n is equal to half of xn minus x of minus n. Okay, so in this way we can represent the even part of a signal as well as the odd part of a signal. Okay, now we will move towards the system, because already I have told about the different types of signal, that is the energy signal, power signal, periodic signal, aperiodic signal, event signal, odd signal, as well as there are another types of signals are there. There is the exponential signals, where it is exponentially increasing signal are there, exponentially decaying signal are there. Okay, as well as there are random signals are there. Random signals means whose value you cannot define, it is random. Noise signal is one type of random signal. Okay, there whose value you cannot predict, random values are there. Okay, noise another, as well as there is some deterministic signal is there. Deterministic signal means where we will get some finite value. Okay, that means suppose we consider a sinusoidal signal, there is some finite value will be there, will always value, is value varies between -1 to +1. Okay, similarly cosinusoidal signal, this is also a deterministic signal, okay, whose value varies between -1 to +1. Okay, so there are another different types of signals are there. Now I will move to the systems. Suppose we represent the system like this way. Yn, I have written Yn is equal to T of Xn. Okay, what is the system? System means after performing some operation on the input signal, we are getting some output signal. Okay, that means Yn is equal to T of Xn, where T we write, we represent T as a operator. After performing some operation on the input signal, we are getting the output signal. So that's why here T is called the operator. Okay, so in this way we represent the system. Okay, so now there are different types of systems are there, that is linear system, non-linear system, time variant system, time invariant system, causal system, non-causal system. There are different types of systems are there. Okay, linear system means which obeys the principle of superposition as well as the principle of homogeneity. This is the linear system. Okay, non-linear system means which does not follow this, then that system is called the non-linear system. Time variant system means for the, if the input in time invariant system means if the input is delayed by k samples, output must be delayed by the k sample. that type of system are called the time invariant system. If that condition is not satisfied, then the system is called the time variant system. Then the causal system is also there. In causal system, output depends upon the present input as well as in the past present output. Output always depends upon the present input as well as on the past input, but does not depends upon the future input. Okay, then that type of system are called the causal system. Okay, there is a non-causal system is also there. Okay, in the next class I will tell about the different types of systems. Okay, so thank you.